So welcome back, dear students, to my spectroscopy class. Today I am going to mention about the hyperfine splitting in connection with the ESR spectroscopy. Okay, that is the hyperfine splitting. Hyperfine splitting in ESR spectrum. So to explain the term hyperfine splitting, that is the spin magnetic moment. You know that the electron in a free radicals or the molecular species containing unpaired electron or paramagnetic species have a resultant spin or a resultant spin magnetic moments, and the spin magnetic moment S bar, the spin magnetic moment S bar of the unpaired electron can interact with the spin magnetic moment the spin magnetic moment mu of the unpaired the mu of the neighboring nuclei having I is not equal to 0 or I greater than 0. Okay, the spin magnetic moment I of the neighboring nuclei. Nearby nuclei having possessing resultant spin moment with I is not equal to 0, and thereby in the molecular species, and thereby the results in the splitting of the ESR spectral line, results in the splitting of the spectral line into further 2I plus component, into further components. Okay, or the ESR that results in the splitting of the ESR absorption signal into a number of components. If I is the spin angular momentum is of the nucleus, then the signal or ESR line is split into 2I plus 1 lines or components. Okay. So depending on the the ESR line is split into 2I plus 1 lines or signals into the ESR resulting ESR spectrum, and this is called hyperfine splitting. It is analogous to that is called spin-spin coupling in the case of the NMR spectroscopy. Okay. Just like the NMR spectroscopy, it is a counterpart of NMR spectroscopy. That is the spin coupling is there, just like that. Here, the spin magnetic moment S of the unpaired electron can interact with the spin magnetic moment of the neighboring nuclei with the I is not equal to 0 or I greater than 0, which results in the splitting of the absorption signal into 2I plus 1 component, into number of components. This splitting of the ESR signal due to MS and MI interaction. It is due to the MS interact and MI interaction. Okay, is known as hyperfine splitting. Okay, the interaction between MS and MI, okay, of the nucleus, the interaction of MS of the electron, the interaction between the MS of the unpaired electron and MI of the nuclei results in the splitting of each MS spin energy level into different EMS MI level. Mi spin level. So there are, okay, how many spin energy levels are then possible due to hyperfine splitting? Suppose in a molecular species, if n is the number of equivalent nucleus or proton with unpaired nuclear spin, then the number of energy levels, the ms energy level is splitted into into 2 into n plus 1 component level. So the ms energy level, okay, for even in the case of an unpaired electronic species, the molecular species contain one unpaired electron, there are 2 spin level, that is ms is equal to minus half lower energy level and ms is equal to plus half, that is higher energy level, the spin energy level. Each such ms level interact with the mi or I of the nucleus, resulting in the splitting of the energy level into EMS Mi. There are 2 into n plus 1, 2 into n plus 1 number of energy levels, EMS bar EMI, where n is the number of unpaired or number of nucleus or number of proton with the unpaired nucleus spin, where n represent the number of equivalent proton, or nuclei, the n represent the nuclei with the resulting spin. Okay, I is not equal to 0. It represents the number of nuclei with the I is not equal to 0. You have to remember to study 2 important things. That is the number of lines. The number of component lines are split into 2i plus 1 lines or signals, and the number of, this is the number of lines, and the number of energy levels. Number of energy levels, that is E, Ms, Mi is 2 into n plus 1. 2 into n plus 1, where n is the number of nuclei, equivalent nuclei with unpaired with I not is equal to 0, equivalent nuclei. N is the number, or it is equal to the number of line is equal to n plus 1. Okay, 2i plus 1, or it is equal to 2 into n into I plus 1, or that is equal to I is always half, 2 into n into half plus 1, that is equal to n plus 1 lines or peak. So you have to remember, you can follow this thing, the number of the lines, the number of hyperfine line that is splitting is either 2i plus 1, or is it 2n into i plus 1, or it is n plus 1 lines, and the number of the number of energy levels splitting is equal to 2 into, if n plus 1 is the number of lines, okay, n1 plus represents the number of lines, and the energy level is 2 into n plus 1. So come to again, what is hyperfine splitting? So in the case of a molecular species containing unpaired electron, the spin angular momentum S bar of the electron can interact with the spin magnetic moments mu of the neighboring nuclei with I is not is equal to 0. And thereby it results in the splitting of the ESR absorption signal into number of component lines. Suppose I is the spin of the nuclei, then the number of splitting is 2I plus 1. Or is n is the number of nuclei, neighboring nuclei equal to neighboring nuclei, then the number of line is 2 is equal to n plus 1. Okay. So there are 2I plus 1 line or there are n plus 1 lines due to the hyperfine splitting, and this splitting is called hyperfine splitting, and practically an ESR spectrum is a spectrum that represents the hyperfine splitting also. Okay. Then again, the number of energy levels, that is due to the interaction between the ms of an electron, unpaired electron, with the mi of the nucleus, results in the splitting of each ms level into different spin energy level, that is EMS, comma EMI. Okay, EMS, EMI, that is this is the splitting of ms energy level into different spin energy level EMS, MI, and the number of such energy levels are 2 into n plus 1. So the number of such energy levels that is splitted is, or the ms energy level is splitted into 2 into n plus 1 energy level due to the hyperfine splitting, where n is the number of equivalent neighboring proton present in the molecular species. When it is a number of equivalent neighboring proton, is a number of equivalent neighboring proton present in the molecular species along with the proton, along with the unpaired electron. So consider the case. Consider the case. So it can be represented like this. That is, due to the hyperfine splitting, 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 the number of energy levels are 2 into n plus 1 E ms mi. Okay, EMS like that, number of energy level, that is E ms mi equal to 2 into n plus 1. Then the number of lines due to splitting is equal to 2I plus 1 or is equal to n plus 1, where n is the number of equivalent proton, number of equivalent proton or neighboring equivalent proton in the molecular species, or I is the spin quantum number of the nucleus or proton. The energy level of the components MSMI is given by, okay, the energy level EMS MI is equal to, mathematically is given by G beta B0 EMS plus A into ms into mi. This is a theoretical, where A is called hyperfine splitting constant. The A is called the hyperfine splitting constant. Ms is the spin magnetic quantum number of the unpaired electron. Okay, Mi is the spin magnetic moment of the nucleus or spin quantum number. Ms represents spin quantum number of the unpaired electron, and Mi represents the spin quantum number of the nuclei, neighboring nuclei with I is not equal to 0. Okay, G is the nuclear electron G factor, beta is called the Bohr magnetron, B0 is the applied magnetic field. So this is a theoretical representation. That is, thus, due to the interaction between each Ms with each Mi, we get different Ms Mi spin level. So depending on the combination or interaction of Ms with the Mi present in the nuclei, we get a different combination of energy level of Ms and Mi, that is a hyperfine splitting. The simplest case is a radical molecular species with one proton and one unpaired electron, that is a hydrogen atom. Consider the ESR splitting, hyperfine splitting of hydrogen atom. The simplest case. The simplest case is that of simplest ESR spectrum showing the hyperfine splitting is that of hydrogen atom. Hydrogen atom is a system with one unpaired electron and a proton, one proton with I is not equal to 0, I is equal to half. So hydrogen atom is a species with Ms with a one unpaired electron and one proton. So in this case we have Ms is equal to plus or minus half always, and Mi is equal to plus half or minus half, or plus or minus half. So the situation here can be represented as, so due to the various combination that I have to this is the energy E. So we have initially the spin moment of the electron with the unpaired electron with the plus or minus half, and the B is equal to 0, no fields. Okay, then under the influence of the applied fields, B0 is split into two. It's going to split it into two energy levels. That is equal to Ms is equal to minus half or lower energy. Okay, remember the case of the ESR splitting, the plus or minus half is split into Ms is equal to minus half of lower energy and Ms is equal to plus half of higher energy. That is how first splitting. Okay, again, so between these various energy levels, so between the various possible Ms, Mi, there are transition are possible, various transition are possible, and this transition are governed by the quantum mechanical selection rule for ESR, that is delta Ms should be equal to plus or minus 1 and delta Mi should be equal to 0. This is called the quantum mechanical selection rule for ESR spectroscopy on accounting the hyperfine structure. So the actual quantum mechanical selection rule governing the ESR spectroscopy is the transition between the various possible spin energy level in a paramagnetic species is such that delta Ms should be equal to plus or minus 1. Okay, delta Ms, the change in spin level, electronic spin level should be equal to plus or minus 1. But the change in magnetic spin level should be equal to the nuclear spin level should be equal to 0. Then delta ms is plus or minus 1, but delta mi is equal to 0. So the transition is mainly controlled by the combined simultaneous effect of these two quantum selection. So in ESR spectroscopy, the transition between the various spin energy levels, various spin energy, hyperfine spin energy levels or spin energy levels are controlled by the combined quantum mechanical selection rule. That is combined and simultaneous. Delta ms is plus or minus 1 and delta mi is equal to 0. This random. Both should be fulfilled. So the combined or simultaneous quantum mechanical selection rule is to be fulfilled for the transition between any two energy levels. Okay. So in the case of the first situation, the case of hydrogen atom with the one unpaired electron and one proton, so the various combination or the spin, under the influence of the magnetic field, the electronic spin level is split into two energy level, ms is equal to minus half and ms is equal to plus half. And this will interact, okay, with the spin of the proton. The spin of the proton mi is equal to plus half or minus half. What do you know? Is plus half or minus half. So when it interacts with the mi interacts with the plus half. In case of nuclear energy level, plus half is lower energy level normally. So we have the energy rate E minus half plus half. And another state is E is equal to E minus half and minus half. Okay. So the ms minus half interact with the mi plus or minus half. We have two energy levels, that is E minus half plus half and E minus half minus half. Similarly, the ms is equal to plus half can interact with mi, okay, plus or minus half. Here we have the energy splitting is such that mi is upper energy, mi plus is minus half here. So we have the E is equal to plus half minus half, and here E is equal to E plus half, combination plus half, then plus half, then plus half. So we have the splitting, hyperfine splitting. You require. So we have the hyperfine split. In the case of hydrogen atom, the two energy levels formally present, that is ms is equal to minus half and ms is equal to plus half. Now split into four lines, split into four energy spin level due to the mi interaction. That is the minus ms will minus half interact with the mi is plus or minus half, and we have two energy level, E is minus half plus half and E minus half minus half. Similarly, ms equal to plus half interact with mi plus or minus half to give E plus half minus half and E plus half plus half. So there are four energy levels due to the hyperfine splitting. That is, the levels are E, ms, mi. So 4 ms, mi. Levels are 4 numbers, and the number of transition possible transition. The transition here. Transition is given by delta ms is equal to plus or minus 1 and delta mi should be equal to 0. This control these are the only transition possible. Okay, this is one transition, that is, you look here, you have the plus half minus half, plus half minus half, So ms is plus half minus half, that is your 1. So it is fulfilled. Then mi minus half minus half, that is minus half plus half, that is 0. So in these cases, this is fulfilled simultaneously. Then another is this. This is another transition. Here also ms is plus or minus 1 plus half minus half, that is 1, is fulfilled. Then mi plus half minus plus half, that is plus half minus half, that is 0. So in this case, this is also fulfilled. So the two transitions are possible, and these two transitions produce two line or two signal in the ESR spectrum. So when we look into the ESR spectroid in atom, respond to these two transitions, these energy levels. So okay, this energy level is the order, that is E minus half plus half, the lower energy than E minus half is lower in energy than E plus half minus half is lower in energy than E plus half plus half. So you can put a comma here. So this is the possible energy levels, order of the energy levels. And there are how many line signal? 2 signals, 2 lines, 4 energy levels. And the spectra on protein, the derivative curve, we are using the derivative curve, that is ds by dv. The derivative curve consists of this beta 0, V0, applied potential magnetic field here. The signality is like this. Signal. This is a type of the signal obtained. So here it is a doublet. So a doublet. So the ESR spectrum of hydrogen atom thus appears to be a doublet, or it consists of 2 lines. Okay, with our 2 peaks. So it consists of n plus 1. You put the number and number of proton is identity proton is 1. So 1 plus 1. There are 2 lines or 2 peaks. Here is a spectrum, or it appears the doublet. Then let's consider the second case, the methyl radical. If there are more than 1 identical nuclei. This is a string case. We have discussed the simplest case of a molecular species or radical consists of a single proton or single unpaired nucleus. If there are more than 1 equivalent proton with a spin, I is equal to not equal to 0, the situation is different. So in the case of methyl radical CH3 radical. The case of CH3 radical interaction consists of 1 unpaired electron and 3 equivalent neighboring proton. This is the situation. So in the methyl free radical, the situation is such that there is 1 unpaired electron and 3 equivalent neighboring proton. So the ms is equal to plus or minus half of the unpaired electron can interact with the various mi combination of various mi or the 3 unpaired 3 spinning nuclei. With the 3 spinning nuclei, there are 3 equivalent proton here. So the 3 equivalent proton, there are number with the 3 equivalent proton with the maximum I possible that is 3 by 2. Okay, 3 by 2. So the various combination are I is MIR plus 3 by 2 minus half, then plus half and minus that is okay. The various MI combination are plus 3 by 2 plus half, then minus half, then minus 3 by 2. These are the four possible MI. The spin quantity for I is equal to for a methyl radical with the 3 equivalent proton, the I are 3 by 2. So the MI possible are plus 3 by 2 plus half minus half minus 3 by 2. These are the possible combination of MI, that is 2I plus 1. MI possible are MI is equal to I plus 1. So 2 into 3 by 2 plus 1, that is equal to 4. So 4 MI are possible. Okay, നമ്മൾ അറേഞ്ച് ചെയ്ത് കിട്ടും. I എന്ന് പറയുന്നത് 3 by 2 ഉണ്ടാവും, I plus half ഉണ്ടാവും, I minus half ഉണ്ടാവും, I minus 3 by 2 ഉണ്ടാവും. So here the thing is that the case of proton methyl radical with the 3 proton, the corresponding I is 3 by 2. The MI possible are plus 3 by 2 plus half minus half and minus 3 by 2. So MS plus or minus can interact with each of these MI and resulting in how many spectral line? So 2 into 2, how many spectral line? How many energy levels? 2 into this plus or minus half. Okay, MS is equal to plus or minus a half can interact with MI with the 4 values. The 4 values will make interact here. That is 2 into n plus 1 energy level E MS MI, that is equal to 2 into 3 plus 1, that is equal to 8 E MS MI. So first remember studies that the case of methyl radical, the energy levels are split into 8 energy levels. So due to the hyperfine electron nucleus interaction, MI interaction, there are 8 spin energy levels are possible. 8 MS MI combination are possible. They are. And the number of lines, the number of signals are n plus 1, that is equal to 3 plus 1, that is 4 lines. 4 lines or 4 peaks are possible. Now the transition, so the number of transition are n plus 1 or 3 plus 1, 4 transition, and 4 lines or 4 peaks, or consider quadruplets. Okay, 4 line and then quadruplet ആയിട്ടാണ് നമുക്ക് appear ചെയ്യുന്നത് ഇതിന്റെ spectrum. Yes sir, ഇതിന്റെ various combination എഴുതാം നമുക്ക്. The various combination are, the various energy level combination are, ഇത് വെച്ചിട്ടാണ് എഴുതുന്നത്. That is MS plus half MS minus half. Then MI is equal to plus 3 by 2 plus half minus 3 by 2 combination. We have the various energy levels are in the order. That is E minus half MS ആണ്. Okay, various E MS MI ഇതാണ് നമ്മൾ എഴുതുന്നത്. E minus half plus 3 by 2 lesser than E minus half, then plus half is lesser than, okay, E plus minus half, then E minus half comma, minus half is lesser energy than E minus half this, minus half minus 3 by 2. Then lesser than ms E ms plus half comma then plus half comma minus 3 by 2. Okay, sorry, plus 3 by 2 ആണെങ്കിൽ ഇനി എടുക്കേണ്ടത് അവിടുത്തെ എനർജി ലെവൽ minus 3 by 2 ആണ്. minus 3 by 2 then lesser than E plus half minus half then lesser E is equal to plus half. Okay, E plus half then plus 3 by 2 plus 3 by plus half then lesser than E plus half comma plus 3 by 2. So there are 8 levels. So there are 8 energy levels are possible and this can be represented like നോക്കാം ഇവിടെ ഇങ്ങനെ റെപ്രസെന്റ് ചെയ്യാൻ നോക്കാം. Various combination possible. A, that is S is equal to plus or minus half, no field, is equal to 0, then നമ്മൾ ഇതിനെ സ്പ്ലിറ്റ് ചെയ്യുകയാണ്. B0 okay ms is equal to minus half, ms is equal to plus half. And these are going to interact with them. ഇത് 4 ഇതുമായിട്ട് interact ചെയ്യാൻ പോകണം. Interact into 4 lines. Okay, 4 interaction വേണം. അതാണ് നമുക്ക് എഴുതാം. അതുപോലെ ഇത് 4 എണ്ണമായിട്ട് interact ചെയ്യും. mi നമുക്ക് നോക്കാം. ഈ 4 ഇന്ററാക്ഷൻ എന്ന് പറയുമ്പോൾ നമുക്ക് എനർജി ലെവൽസ് ആണ് എഴുതുന്നത്. മൈനസ് ഹാഫ് ഓക്കെ ഇ മൈനസ് ഹാഫ് പ്ലസ് 3 by 2 E minus half plus half E okay minus half okay minus half E minus half minus 3 by 2. ഇത് 4 കോമ്പിനേഷൻ. അടുത്തത് E പ്ലസ് ഹാഫ് എം എസ് ആണ്. ഇനി എം ഐ എടുക്കുക. എം എന്ന് പറയുന്നത് നേരെ തിരിക്കണം. ഇവിടെ നേരത്തെ നേരെ തിരിക്കും. minus 3 by 2 E plus half minus half then E plus half എന്നുകൊണ്ട് okay plus half E plus half plus 3 by 2. അങ്ങനെ 8 എനർജി ലെവൽസ് ഉണ്ട്. Then the transition, various transition. So the various transition possible are governed by that to be governed by fulfilled by simultaneous fulfillment of transition delta ms is equal to plus or minus 1 and delta mi is equal to 0. This is the selection rule for transition. ESR transition. ഇത് നമ്മൾ കൺട്രോൾ ചെയ്ത് കഴിഞ്ഞാൽ the transition process രണ്ടും ഒരേ സമയം നോക്കുക. അത് വെച്ചിട്ട് ഞാൻ എഴുതാം. നിങ്ങളെ ചെക്ക് ചെയ്യുക. ഞാൻ ഇപ്പൊ വേഗം എഴുതാം. This is the one possible. ഇവിടെ ഈ രണ്ടും ഒരേ സമയം കൺട്രോൾ ചെയ്യും. ms പ്ലസ് 1 ആണ് പ്ലസ് മൈനസ് ആണ്. mi 0 ആകുന്ന ട്രാൻസിഷൻ അനുഭവിച്ചിട്ടുള്ളൂ. then this is transition. You check this. Possible. Then this is the another transition possible, and this is the another transition that is possible. ഇത് നിങ്ങൾ ചെക്ക് ചെയ്താൽ മതി. ആദ്യത്തെ വാല്യൂ +1 കിട്ടണം, രണ്ടാമത്തെ വാല്യൂ 0 കിട്ടണം. ഇത് ആ രീതിയിലുള്ള ട്രാൻസിഷൻ ആണ് പോസിബിൾ. സോ ഈ റൂൾ ഓഫ് 4 ട്രാൻസിഷൻ and hence 4 lines or 4 peaks or quadrilates. So the ESR spectra consists of a quadrilates. Let's like this. Yes, ESR spectra is going to draw the ESR spectrum. ds by dB versus B0. This is the line. So this is the first transition. Okay, I am writing represent like this. 1, 3 lines. This is the line. So there are 4 lines. 1, 2, 3, 4 or 4 peaks. 1, 2, 3, 4. These are hyperfine. The transition represent another. I could discuss in the there is 4 peaks or 4 lines. The next, finally, we have to discuss about the ESR spectrum. So in the case of general equation apply here. So n plus 1, that is 3 plus 1, 4 lines. 4 lines or peaks. Then energy levels 2 into n plus 1 energy level. That is 2 into 3 plus 1, 4. 8 energy levels. Okay, E0, E, MS, MI. And finally, consider the case of phenyl radical. So more than one identical proton are the example. The case of ESR spectrum of phenyl radical. Okay, that is C6H5 radical. It is represented like this. So this is a system. Phenyl radical is a system containing one unpaired electron. Electron with the EMS is equal to plus or minus half. And it consists of five equivalent neighboring proton with the I greater than 0. 5 equivalent proton under. So that thing. What is the MI value? MI of this proton total, sorry, I is I. The I value of the here is there are 5 proton. For 5 proton the I values are, the I is, okay, and the various combination of I at the 5 by 2, I is equal to 5 by 2, maximum I possible. For these 5 protons are 5, I is 5 by 2. Therefore the quantum number MI, the spin quantum number of the nuclear is how many possible MI value are? The possible MI value are, MI is equal to the possible corresponding to I5 is 5 by 2, the possible MI are plus 5 by 2, 2I plus 1, 2I plus 1 value. There are 2 into 5 by 2 plus 1, that is 6 values. Okay, 6 values, that is I is equal to 5 plus 5 by 2 plus 3 by 2 plus half. Okay, I is equal to plus 5 by 2 plus 3 by 2 plus half, then minus 5 by 2 minus half minus 3 by 2 and minus 5 by 2. So these are the 6 mi value are plus 5 by 2 plus 3 by 2 plus half, minus 3 by 2 and minus 5 by 2. So the various combination of energy levels, the energy level E, ms, mi are the number of ms are 2 into n plus 1, that is 2 into 5 plus 1, that is 12 energy levels. 12 energy levels are possible. So there are 12 E, ms, mi level. What is the various combination of this with this? Okay. ഈ രണ്ടും ഈ ആറും കൂടെ നമുക്ക് 12 ES MI ഉണ്ടാവും. Then the transition, variable transition possible are with the selection rule. That is the various n plus 1 transition, n plus 1, that is equal to 5 plus 1, that is equal to 6 transition. 6 transition according to the selection rule, or therefore there is 6 peak or 6 lines. R line അല്ലെങ്കിൽ R, അതാണ് നമുക്ക് represent ചെയ്യാൻ പോകുന്നത്. So we are going to represent that. quickly. എന്നുവെച്ചാൽ എഴുതാൻ ബുദ്ധിമുട്ടുണ്ട്, വേണമെങ്കിൽ നിങ്ങൾക്ക് എഴുതാം. ഓക്കെ, എഴുതണമെന്നുണ്ടെങ്കിൽ നിങ്ങൾക്ക് എഴുതാം. എങ്ങനെയാണ് എന്നുള്ളതാണ് എനർജി ലെവൽ നമുക്ക് എഴുതണമെന്നുണ്ടെങ്കിൽ പണിയുണ്ട്. ഓക്കെ, ഐ വിൽ റൈറ്റ്. ഓക്കെ, നമുക്ക് എഴുതാം. ഈസ് ഈക്വൽ ടു നമുക്ക് ഇങ്ങനെ വേണ്ടി എഴുതാം. A is equal to plus or minus half, B is equal to 0, F1 is equal to minus half, ms is equal to plus half for electron and beta electron. Then you are going to interact. Okay, the R which moving. Mi 6 value alle 6 value mi 6 value ഉണ്ട്. അത് നമുക്ക് എഴുതാൻ പറ്റത്തില്ല. ഞാനത് 6 ആയിട്ട് സ്പ്ലിറ്റ് ചെയ്യാൻ പോവാണ്. ഇത് that is E minus half comma plus 5 by 2, then E minus half plus 3 by 2. Okay, then E minus half plus half, E minus half ഇത് മൂന്നെണ്ണം കൂടെ വരും. E minus half comma minus half, then E minus half minus 3 by 2, then E minus half plus 5 by 2 minus 5 by 2. 3. Okay, so we have 1 2 3 4 5 6. Similarly, 6 ഇവിടെയും ഉദാഹരണം വരെ പടം വരച്ചിട്ട് ക്ലിയർ ആയിട്ടില്ല. ഇവിടെ വരും 6 5 ലെവൽ ഇവിടെ വരും. ഇതൊന്നുകൂടെ കറക്റ്റായിട്ട് വരയ്ക്കണമായിരുന്നു. അതവിടെ തെറ്റിയതാണ്, കിട്ടിയല്ല, അത് പിക്ചോറിക്കൽ പ്രശ്നം ഉണ്ടാകുന്നുണ്ട്. So this is E. E plus half minus 5 by 2 A plus half minus 3 by 2 A plus half minus half, then E plus half, then E plus half comma plus 3 by 2, and finally E plus half plus 5 by 2. ഇച്ചിരി ബുദ്ധിമുട്ടുണ്ടായിരിക്കാം. ഇത് നമുക്ക് വേരിയസ് കോമ്പിനേഷൻ ആണ് ട്രാൻസിഷൻ ഉണ്ടാകുക. അത് എഴുതാൻ നിങ്ങൾ ഡെൽറ്റ എം ഐ ഈസ് ഈക്വൽ ടു 0 എന്നും ഡെൽറ്റ എം എസ് അറിയാം പ്ലസ് ഓർ മൈനസ് 1 എന്നും ഡെൽറ്റ എം ഐ ഈസ് ഈക്വൽ ടു 0 എന്ന അത് കണ്ടുപിടിച്ചു കഴിഞ്ഞാൽ there are 6 transition. So we have a 6 transition are possible and 6 peak for 6 lines. 6 ലൈനുകൾ ഉണ്ടാവും. അത് നമുക്ക് ഇതിൽ നിന്ന് എഴുതാൻ പറ്റും. ഓക്കെ, അത് നിങ്ങൾ എഴുതുക. നമ്മുടെ പീക്ക് എന്ന് പറയുന്ന ഈ ഇത് വെച്ചിട്ടാണ് നമ്മൾ എഴുതുന്നത്. സോ ദാറ്റ് കൺസിസ്റ്റ് ഓഫ് ds by db. d0 ഇയാള് ഇങ്ങനെ വരും. ഒന്ന് രണ്ട് മൂന്ന് നാല് അഞ്ച്. So the 1, 2, 3, 4, 5, 6 lines or number between 1, 2, 3, 4, 5, 6 picture ഉണ്ടാവും. This is the ESR spectrum. 6 transition, 6 peak or 6 line. 6 lines. ഇപ്പോൾ ട്രാൻസിഷൻ നിങ്ങൾ എഴുതാനുള്ള ഇത്രയും കാര്യം ശ്രദ്ധിച്ചാൽ മതി. You have to follow delta ms plus or minus 1 ഉം delta mi 0 കമ്പൈൻഡ് ആയിട്ട് വരുന്ന ട്രാൻസിഷൻ ആണ് നിങ്ങൾ എഴുതേണ്ടത്. അതായത് ഇത് രണ്ടും കൂടെ ചേരുമ്പോൾ ഇതും പ്ലസ് 1 വരണം, ഇത് 0 വരണം. അങ്ങനെയുള്ള കോമ്പിനേഷൻ എഴുതുമ്പോൾ 6 കോമ്പിനേഷൻ കിട്ടും. 6 ലൈൻ ട്രാൻസിഷൻ. ഇതുപോലെ തന്നെ വ്യത്യസ്തമായ റാഡിക്കൽ, ട്രൈഫീനയിൽ, കപ്രൈൽ റാഡിക്കൽ, ഓക്ടൈൽ റാഡിക്കൽ, അങ്ങനെ ഒരുപാട് റാഡിക്കൽ നിങ്ങൾക്ക് ഉണ്ട്. അല്ലെങ്കിൽ എഴുതി പഠിക്കുന്ന പുസ്തകത്തിന് വേറെ എക്സാമ്പിൾ കിടപ്പുണ്ട്. ദാറ്റ് ഈസ് സൈക്ലോപെൻഡ ട്രൈനെ റാഡിക്കൽ പുസ്തകത്തിൽ കിടപ്പുണ്ട്. So it is a system consists of 6 identical, 7 identical protonകളാണ്. അത് നിങ്ങൾ വരച്ചു നോക്കുക. Then application of ESR spectra. It is mainly studied for the reaction mechanism to detect the free radical, study of the ionization, irradiation in matter. Okay, radiation chemistry പഠിക്കാൻ ഉപയോഗിക്കുന്നുണ്ട്. റിലേറ്റീവ് കോൺസെൻട്രേഷൻ ഫ്രീ റാഡിക്കൽ പഠിക്കാനുണ്ട്. അപ്പോൾ മെയിനായിട്ട് ഫ്രീ റാഡിക്കൽ ഐഡന്റിഫൈ ചെയ്യാനുള്ളതാണ്. റാഡിക്കൽ വഴിയുള്ള മെക്കാനിസം പഠിക്കാൻ ഉപയോഗിക്കുന്നു. റേഡിയേഷൻ ഇൻഡ്യൂസ്ഡ് റിയാക്ഷന്റെ മെക്കാനിസം പഠിക്കാൻ ഉപയോഗിക്കുന്നു. ഓൾ ദീസ് ആർ ആൻഡ് റിയാക്ഷൻ റിലേറ്റീവ് കോൺസെൻട്രേഷൻ ഓഫ് ദ ഫ്രീ റാഡിക്കൽസ്. ഇത്രയാണ് നിങ്ങൾ ഇതിന്റെ ആപ്ലിക്കേഷൻ പുസ്തകം വായിക്കുക. ടൈമിംഗ് വൈൻഡിംഗ് അപ്പ് ദ ക്ലാസ്. താങ്ക് യു വെരി മച്ച്. സോ ഇതോടുകൂടി നമ്മുടെ ESR ഹാസ് ഫിനിഷ്. താങ്ക് യു.